So this is also one of the questions that has been asked in a competitive examination. So the question is, among SF4, ClO4 minus, FClO3 and IF4 plus, the number of species having seesaw shape is, so the first option is 2, second option is 1, third option is 3 and fourth option is 4. So that means amongst these compounds we have to find out that which of the following have the seesaw shape, and what number of compounds have the seesaw shape. So we have 4 compounds, and out of 4 how many have seesaw shape. So we will apply VSEPR theory here to predict the geometry and the shape of the compounds. Now let's start with SF4. SF4 has sulfur as the central atom, and the number of valence electrons in sulfur is 6. It belongs to the oxygen family, so the number of valence electron in sulfur will be 6. So the first step of VSEPR theory is finding the number of valence electrons in the central atom. Then how many electrons are contributed by the atom which is bonded to the central atom? So we have 4 fluorine atoms, so 4 electrons, okay? And then we find out the total number of electron pairs. So total number of electron pairs will be 6 plus 4 divided by 2, that is 5 electron pairs. And then how many bond pairs are there? So sulfur is bonded to 4 fluorine atoms, so number of bond pairs will be 4. And then the number of lone pairs. So number of lone pairs will be total number of electron pairs minus the number of bond pairs, which is equal to 1. So we have 1 lone pair. Now when the total number of electron pairs is 5, then the regular geometry according to VSEPR theory is trigonal bipyramidal, TBP. Okay, but when we have a lone pair, then the geometry gets distorted to a different shape. Now if we try to make a TBP geometry, so this, okay, and then we have 1 lone pair in the equatorial position. So basically we know how the TBP geometry exists. So trigonal bipyramidal is something like this. So if we have A as the central atom, then we have something like this. So this kind of trigonal shape, and then 1 above and 1 below. Then something like this is the TBP geometry, okay? And these are the 5 atoms that are present in the regular TBP geometry. Now here we have 4 atoms and 1 lone pair. So mostly we place the lone pairs in the equatorial position. Why? In order to avoid the repulsion, bond pair, lone pair repulsion. Now if we try to see this structure carefully, then okay, let me make it in a horizontal fashion. So it's the view is vertical. So if I make it like this, so S, so both sides this axial F fluoro, and then these 2 equatorial fluorine atoms. Now how it looks? It looks like a seesaw. So this shape is a seesaw shape, okay? So we have something like this, seesaw shape. Okay, so SF4 has a seesaw shape with 1 lone pair of electrons oriented in the equatorial position. So among the 4, SF4 has seesaw shape. Now let's move on to the ClO4 minus compound. Now for ClO4 minus ion, the central atom is obviously chlorine. Then the number of valence electrons in chlorine, so it belongs to the 7th group, so 7 valence electrons. And now how many electrons are contributed by the bonded atom, that is oxygen? That is equal to 4, okay, so it is O4, so 4 electrons, and there is 1 negative charge. But since the oxygens, which could be doubly bonded, and VSEPR theory considers only the sigma bonded atoms, so we will ignore this part, oxygen, okay? And then For total number of electron pairs, we will add up only the valence electrons in Cl and one negative charge. And that will be 7 plus 1 divided by 2. 8 divided by 2 is 4. Okay, so the total number of electron pairs is 4. Now, how many bond pairs? Now, when we consider the bond pairs, obviously we will consider only the sigma bonded pairs. Okay, so if at all oxygen has double bonds for which we ignore the number of electrons gained from it, we consider only the sigma bonds. So even if oxygen has double bond, we will consider 1, 1, 1, 1 each. So 4 oxygens will give rise to 4 bond pairs. Here we cannot ignore everything because in double bond we have 1 sigma bond and 1 pi bond. So the number of bond pairs from O4, that will be 4. Okay, because each of them has 1 sigma bond. And then the number of lone pairs. How many lone pairs we can have? So total number of electron pairs is 4 minus bond pair 4. So there are no lone pairs. And if there are no lone pairs, that means the geometry which arises from the total number of electron pairs is a regular geometry. And that is the tetrahedral geometry. So ClO4 would be something like this. Okay, tetrahedral. So here 1 oxygen and then here. Okay, like this, and the negative charge. So it could be something like this, ClO4, which is having a tetrahedral geometry. That means it is not in the seesaw shape. So this option is gone. Now going back to the question, what is the next compound? FClO3. Now let's check FClO3. Now here, which one should be the central atom? So according to VSEPR, the atom having least electronegativity is the central atom. Here, if we compare between fluorine, chlorine and oxygen, so chlorine is having least electronegativity among all the 3 atoms. So chlorine becomes the central atom in this compound. Now the number of valence electrons in chlorine. So it should be 7, belonging to the 7th group. So number of valence electrons in chlorine is 7. Now how many electrons are gained through other atoms? So oxygen we will omit here again due to the presence of the double bonds, and we will consider only the electrons gained from fluorine. So it will be 1. 1 fluorine, 1 electron. Now the total number of electron pairs, 7 plus 1 by 2 is 4. Now how many bond pairs we have? So we have 1 fluorine, okay. So 1 bond pair, and then we have 3 oxygens. So 3 oxygens, at least 1 sigma bond each of them should have. So we will count 3 plus 1, that is 4 bonded pairs we have with chlorine atom, which is the central atom. So number of bond pairs should be 4. And then the number of lone pairs. So we have total number of electron pairs 4, bond pairs 4. So number of lone pairs is 0. That means it is a regular geometry, which is tetrahedral geometry. That means FClO3 is also not in seesaw shape. It has a tetrahedral geometry. Now let's move on to the next complex, which is the 4th one. So we have IF4 plus. So let's check IF4 plus. Now here iodine is the central atom, and then the number of valence electrons in iodine is 7, belonging to the 7th group. And then how many number of electrons are contributed from the bonded atom? We have fluorine, 4 fluorine atoms, so 4 electrons. And then we have 1 positive charge. Now the total number of electron pairs should be, so we add the valence electrons of the central atom and then number of electrons which is gained from the bonded atoms, and since we have a positive charge, we have to subtract that charge. Okay, and that is divided by 2. So we have 10 by 2, that is 5. So we have total number of electron pairs 5. And now the number of bond pairs. So we have 4 fluorine atoms. That means the number of bond pairs should be 4. Now how many number of lone pairs? So we have total number of electron pairs 5, number of bond pairs 4. So we have 1 lone pair. The regular geometry with total number of electron pairs as 5 should be, what should be the regular geometry? It should be trigonal bipyramidal geometry. But if we have a single lone pair, that means this TBP geometry gets distorted to the seesaw shape. Okay, if you recall it again, so like this. So we had that SF4, we had 5 total number of electron pairs resulting into TBP geometry. But this TBP geometry gets distorted when we have a lone pair of electrons which is positioned at the equatorial position. Same will happen to IF4 plus also. So we can make it like this. So IF4 plus is seesaw shaped. So coming back to the question, so how many number of compounds are seesaw in shape? So out of 4 we have SF4 and IF4 plus. That means 2 number of compounds. So option 1 should be the correct answer. So I hope this explanation is clear to you and all the best. Thank you.